Hello everyone, and welcome back. In this lesson, we're going to get a quick sense for topology. Topology is part of how our vector data is structured and provides benefits for correcting and validating data, as well as for displaying and analyzing the data. Understanding how it works can help you create higher quality data and know how the inner workings of GIS software run and provide you answers to your questions. The term topology refers to connectivity and adjacency information. Topological information is a sort of metadata, though not visible in our traditional metadata viewers, that helps us define how features interact. Using this information, we can find and prevent errors digitizing data. As a quick summary, topological properties of data are those that won't change if we were to stretch or distort the coordinate space. The common term for this distortion is rubber sheeting, because if we imagine the data printed on a rubber sheet, we can pull the sheet apart to simulate distortion. Distances and angles change in this type of distortion, so they're not topological, but adjacency information, which features touch others, shared boundaries, neighbors, etc., don't, and these are topological properties. In fact, if you remember the options in select by location or spatial join for the types of relationships that we can select by or join on, many of those operations are topological operations. Things like intersection, which polygons contain other polygons, touching boundaries, shared geometry, and more. If we imagine that rubber sheet again, those properties aren't changing as I stretch that sheet. Fortunately for us, improvements in tools and data storage that inherently respect topological rules help prevent us from making editing and digitizing errors. Still, older data formats like shapefiles and older tool sets don't have topological checking and correction built in, so it's important to understand these concepts so you can apply them yourself. I showed one basic way that tools can help us when we learned how to create and edit features, by using the topological editing tools to move a line that defines a shared boundary between polygons. We can make sure that we don't accidentally create gaps between the features or overlaps between the features by moving the line twice. These are two common topological errors. Setting topological rules for data allows us to find and prevent errors from our data's creation. Common rules include that the data must not overlap, or that the data in one layer should overlap and share boundaries with data in another layer, such as counties needing to sum together to make a state. These rules can be part of your data set, or that your GIS software helps you specify when validating an existing data set that doesn't support built-in topology. Topological rules are another kind of integrity constraint, a general database concept for rules we can set that validate fields in our data when they change. The database already checks that we don't put text in an integer field. It can also check for invalid overlaps and gaps in a similar type of check, running automatically and flagging invalid data when we try to update it, thus preventing errors from being introduced in the first place. Topological rules also help with consistency. Having the data storage system manage the rules for what the data should look like or how it should behave means that we can't circumvent the rules on purpose or on accident. Everyone on the team will know what the rules are without having to read and memorize a policy or memo. Topology can also help with performance. When your data already has this relationship information built in, queries against the data in select by location or spatial joins, for example, can be significantly sped up because the software can take shortcuts based on what it learns from the topological information stored in the dataset. If it knows that two features share an edge and a polygon, we know they don't overlap on that edge, so we can skip that calculation. Similarly, the GIS could create an index of locations where edges are shared, speeding up calculations looking for that type of relationship. Topology is very abstract, but if you find yourself doing a lot of data creation, digitizing, or editing, I recommend that you dig deeper into topology, at least as far as it's used in the editing suite. It's an important tool set to understand if you edit data frequently. If you don't regularly do this, then don't forget these concepts, but they might fade to the background a bit. Okay, that's it for this lecture. In this lecture, we covered what the concept of topology is and how rubber sheeting can help us conceptualize it. We reflected back on the topological editing tools and how editing in a topologically aware system can help us prevent errors. We also discussed topological operations in tools like spatial join and select by location, such as intersect, contains, touching boundaries, and more. And finally, we talked about how topology can help GIS move faster. In the next lesson, we're going to talk about using ArcGIS Online. See you next time.